Nebraska has more cattle on feed than any other state and is also the nation's second leading producer of ethanol. Those two sectors are linked because of how ethanol is made. In the production process, plants generate byproducts such as distillers grain, corn oil, corn gluten feed, and corn gluten meal. Livestock producers use those byproducts heavily. University of Nebraska-Lincoln researchers are studying how the changing makeup of distillers grains could impact feedlot diets. Henry Hilscher is a UNL graduate student and the feedlot manager at the Eastern Nebraska Research and Extension Center near Mead. He talked with us there last week to describe that study. We first asked him to explain how distillers grains are used in the cattle feeding industry.
So distillers are a byproduct of the ethanol industry, and we get those from ethanol plants and then we incorporate it into our finishing diets. So we feed here at the feedlot anywhere from 15 to up to 40% of the diet on a dry matter basis. And that helps with our protein needs and also as an energy source to displace corn.
One of the things that's interesting about the ethanol industry is that distillers can change. Tell me why.
So as you know, we've been doing a lot of stuff with the oil removal in the last couple years, and because of that we've also started thinking about what else can they take out at the ethanol plant. And so some of the cellulosic ethanol things have happened to try and reuse that distillers grains as a fiber source and getting some of that out and taking different proteins out for hog and chicken feed. And so we're looking at different components in the diet and replacing those to try and figure out what we're going to be left with in the feedlot one day.
Describe what you did.
So we did a couple studies, one here at UNL at the Research Feedlot in Mead and also at Scotts Bluff, and we just added different components. So we used some different protein sources that are made from the wet milling industry as well as the dry milling industry, and fiber sources, so corn bran, corn gluten meal. We put those pieces together and added it back in to try and equal what distillers grains were in the diet. So tried to have a same nutrient content across all the different diets and looked at what that did on performance.
And then shifting those around to see what would happen if the distillers changed even more?
Yes, sir. So we looked at if we remove the protein out or if we remove the fiber out from the cellulosic ethanol process, what that's going to do for those cattle compared to regular wet distillers grains or dry distillers grains.
And what did you learn?
So we learned that there's a lot of different changes, but there's also a lot of opportunities for using some of those products. So if some of the ethanol industry takes those for another resource, then we're going to be left with something that could still potentially help us out in the feeding industry, cheapen up diets.
Did you notice any differences in gain or how long you had to keep the animals in the feedlot?
So we did everything same days on feed. Performance was different, but not significantly different that we would throw our eyes up and our hands up and worry about seeing those differences.
So this prepares you in case the industry changes even further?
So future research that we're currently doing will be with the corn board and looking at some of those different components. Some of the ethanol plants now are putting those processes in. So we're left with a higher protein distillers grains and also a mixture of what we're calling the solubles or the liquid portion and the fiber component left over after you remove everything else.
Can you just reiterate how important distillers are to the cattle feeding industry?
It's huge. In my time here at UNL, that's all we've ever done, and so it's just amazing that we can feed that and get the gains and performance that we get comparing to just feeding straight corn, and the potential we have for an economic improvement by having such a cheap cost of gain.